Good morning everyone. This is the third part of our video regarding integral, and in this video we are going to discuss about the shortcut, because of which the problem that we are facing to find the sum of the area of the infinite rectangle in the last video, now we can find this very easily. So what was our task? Our task was to find the area under the curve fx. So what we will do at first, we will change this x by delta x. In this case I have increased by delta x, you can also decrease it by delta x. Okay. So similarly, area will also get changed by what? Delta x. And we already know if something changes and if we know the function, we can find the derivative. And what is derivative? It means instantaneous rate of change. And how to find it? We have discussed in the video of derivative. How to find instantaneous rate of change? We find average rate of change in a very small interval. So you see, this is the we are going to find the derivative of the area. That is a dash x. That is average rate of change by delta x, average rate of change of area by delta x in a very small interval, that is instantaneous rate of change. So delta is what? Delta is fx delta x, length into breadth, and we can cancel this delta x because why? Because this delta x is not 0 but it is almost 0. This thing you have already learned in class 11 in the chapter of limits or derivatives, right? This delta x is almost 0 but not 0. So we can cancel this delta x, and what we'll get? We'll get this fx. So finally what we have got? Derivative of area a dash x is the function fx. That means this area ax and the function fx are related. This is the shortcut. This is the coincidence. If you have not guessed it till now, I am telling you, this is the shortcut. We were going to find the area under the curve fx, and if we find the derivative of the area, we get the function itself. So what is the shortcut then? Integral and derivative are related to each other. This is the coincidence, this is the luck, you can say, that was found out by Newton and Leibniz by their research. If you see closely, derivative is a different thing, integral is a different thing. Both are totally different. Derivative tells us about how fast something is changing. Integral tells us about how they are combining, right? How something is combining or gathering. But luckily, coincidentally, they are related. And this became the shortcut. Let us once again see. We need to find area under the curve fx. For the function fx, we need to find the area. And derivative of the area gives fx. This line you remember. Derivative of the area gives fx. We need to find the area. Integral means area. Already discussed in the first video. Integral means area. We need to find the area. And this line, if we find the derivative of the area, we get fx. If we find the derivative of the area, we will get the function fx. So now you see, say for example, we need to find the area of the function fx. Now we don't know how to find the area. We don't have the area, okay? So how to find? Say somehow by any method, by anything, somehow you find a function capital fx. Listen very carefully. Somehow, by any trick, by any method, by doing any kind of logic, somehow you find this function capital fx, a totally different function. And if you find the derivative of this function capital fx, you get fx. Somehow, okay, somehow you have found this function capital fx, and if you find the derivative of this function capital fx, you get the function itself. So if the derivative of this function is capital F, if the derivative of this function is fx, so this fx, capital fx, has to be the area. Because the theory says what? The theory says derivative of the area will be the function. And so this is the area then. So somehow by using any method, we have found out this new function capital fx. And if we can find the derivative of this capital fx. And if it becomes fx, so this has to be the what? This has to be the area then, because derivative of the area is fx. So this is the shortcut, that derivative and integral, they are related to each other. Say for example, you see, say I need to find integral cos x. Okay, integral cos x dx. Now I don't know how to find the answer. Means I need to find the area for this function. I need to find the area for this function, but I don't know how to find it. Somehow, by using some method, I got a function sin x, and if I find the derivative of sin x, I get what? Cos x. somehow if I find this function sin x whose derivative is cos x, so this sin x has to be the what? Area. That means integral of cos x will be what? Sin x. This is the theory. So the process to find this capital Fx is known as integration. The process to find this function, this capital Fx function, is known as integration, and this capital Fx is known as the integral. Okay. And now you may think that okay, this is the shortcut, but how to find this capital Fx function? So no need to take any tension, because lots of mathematicians, by their hard work, by their research work, they have already given us some rules or formulas how to find this capital Fx function. In the different exercise of calculus, 7.1, 7.2, 7.3, in all the exercise, we will get different formulas, and by using these formulas, we will find this capital Fx function. So everything is given for us, everything is ready-madely made for us. We only have to use those rules or formulas to find this capital Fx function. And this capital Fx function is the integral, or you can also say as antiderivative. So this is the shortcut. So the basic shortcut is that what? Integral and derivative are related to each other. So the rules such as, say, integral x to the power n dx, which is equal to what? X to the power n plus 1 by what? N plus 1 plus c. So these are the rules which are already given to us. We only have to use these rules to find what? Capital Fx in the different exercise of the chapter of calculus, right? So I hope you have understood what is the meaning of integration, what is the meaning of integral, what difficulties mathematicians have found while trying to solve the area under the curve, and then finally what is the shortcut given by Newton and Leibniz. The simple shortcut is what? Integral and derivative are related to each other. If you need to find the integral, that is area, and somehow you can find the derivative of this area will be the function itself. So if anyhow we can find a function whose derivative is the given function fx, so then that new function capital Fx will be the what? Will be our area, will be our answer. This is the shortcut. And this symbol is known as integral, which came from the word sum, s, okay, which came from s, and it means what? Summation. It means what? Combining, adding. And the main definition of integral was what? How something is gathering or how something is combining, right? So this s means summation. This symbol means s, and it means what? Summation. So if you have any doubt regarding integral, regarding the concept of integral, so you comment on the video, okay? From the next class, we will start solving the exercise.